3E talks about how numbers can deceive you using polygraphs, mammograms, and more. An example is, who played it better? Kevin had a higher shooting percentage both in the first half, which was 40% to 25%, and in the second half, it was 75% to 70%. Does this mean Kevin had a better shooting percentage for the whole game? So if you look down here, he had a 40% over Kobe, 25%, and in the second half, it was 75% over 70. No, Kevin made a total of 7 baskets. So if you go back and look right here, so if you go ahead and look over here, Kevin got 4 baskets in the first half and 3 baskets in the second half. He had a total of 7 baskets, 4 in the first half and 3 in the second half, on 14 shots. So he took a total of 14 shots and only got 7 baskets. So he got 10 shots in the first half and 4 in the second half, for an overall shooting percentage of 7 out of 4, which is 50%. Kobe made a total of 8 baskets on 14 shots. So he actually got 8 in out of a total of 14 shots he attempted, for an overall shooting percentage of 8 out of 14, which is 57.1%. Even though Kevin had a higher shooting percentage in both halves, Kobe had a better overall shooting percentage for the game. We're going to talk about test results. There are 4 ways that you can get test results. The first one is a true positive. That means a test correctly reports that it is a positive result. Then you can get a false positive, which is a test incorrectly reports that it's positive. So it's actually not positive, but it reports that it is. A true negative is a test that correctly reports a negative result. And a false negative, it incorrectly reports a negative result. So the false positive is actually a negative, a true negative, and a false negative is actually a true positive. Okay, let's look at the examples. Based on the numbers in this table, 3.7, what is the percentage of women with negative test results who actually have cancer? That would be false negatives. All right, so we're going to look up here. Remember, you have to break down the word problem. What is the percentage of women in the negative test results who actually have cancer? So they got a negative test, but they actually do have it, so they got false negatives. Okay, positive mammogram. True positives, there were 85. The tumor was benign. The negative, this is a false negative here. So for 10,000 cases summarized in 3.7, the mammograms were negative for 15 women with cancer and for 8,415 women with the benign. So we'll go back. See right here? 8,415. That's the true negatives. All right. The total number of negative results that you got was the 15 for the false negative plus the 8,415 for the true negative, which gave you a total of 8,430. The percentage of women with false negatives is 15 out of the total, which is 8,430 negatives, which comes out to be 0.0018. And to change it to a percentage, you will take that decimal and move it 2 to the right, so it's 0.18%, or slightly less than 2 in 1,000. In other words, the chances that a woman with a negative mammogram has cancer is a very, very small chance. Polygraphs. Suppose that 1,000 people take a polygraph test, 10 of who lie, and the polygraph is 90% accurate. How many of those applicants who were accused of lying were actually telling the truth? Okay. So if you do a little diagram with this, when you have 1,000 applicants, it said 10 of them who lied. So 10 lied. If you took 10 out of that, that would leave 990 that actually tell the truth. Okay? So when you look back at this, how many of those applicants were accused of lying were actually telling the truth? So here they catch 90% of them. So 90% of 10 is actually 9 liars. If they didn't catch it, that 10% that was inaccurate, that means there's actually 1 liar. These are your true liars. This one was a false. Over here, out of the 990 that tell the truth, remember, they find 90% accurate, so 90% of that is 891 were truthful. But 10% of 990 is 99 people. So these were falsely accused of telling the truth, that 10% that it didn't get. So if you add these together, 9 plus 99, you get 108 accused of lying, but 99 of those were falsely accused, because this is your false positive. High school drug testing. All athletes participating in a regional high school track and field championship must provide a urine sample for a drug test. Those who test positive for the drugs are eliminated from the meet and suspended for competition for the following year. Studies show that at the laboratory selected, the drug tests are 95% accurate. Assuming that 4% of the athletes actually use drugs, what fraction of the athletes who fail the test are falsely accused and therefore suspended without cause? The easiest way to answer this question is by using sample numbers. All right, so suppose there's 1,000 athletes in the meet. We were told that to assume that 4%, so 4% of 1,000 is 40 athletes, actually use drugs. So that means the remaining 960 athletes do not use drugs. In that case, 90% accurate drug tests should use the following results. You want to know what 95% of the 40 athletes who use drugs is. So you would multiply 0.95 times 40. So 38 would test positive for drugs. The other two athletes who uses drugs test negative. Okay, so 95% of the 960 athletes who do not use drugs test negative, but 5% of those test positive. The number of athletes who fail despite not using drugs is the 5% of the 960, so 48. The total number of athletes who test positive is the 38 from the previous slide, down here. 38 test positive for drug use. That here, and then the 48 up here that tested right here, so 86. But 48 of those athletes, or 48 divided by the total 86, 56, are actually non-users. So despite the 95% accuracy of the drug test, more than half of the suspended students are innocent of drug use. All right, let's do political math. Considering the two charts shown on the next slide, both purport to show effects of the tax cut enacted under President Bush in 2001. The chart in figure 3.5a, created by supporters of the tax cut, indicates that the rich ended up paying more under the tax cuts than they would have otherwise. But figure 3.5b, created by the opponents of the tax cut, shows that the rich receive far more benefits from the tax cut than the lower income taxpayers. The two charts therefore seem contradictory, because the first seemed to indicate that the rich paid more, while the second seems to indicate that they paid less. All right, so this is 3.5a over here, and the taxpayer's income level, it'll show you there. Here, we're looking at the high income household receive higher dollar benefits from them. So these are all the benefits that you get. So notice up here, you get more benefits if you make more money, but this is just representing the benefits. This is representing the tax revenue collected. And notice if you're up here in the top 25, you're paying a higher percentage of taxes. So these two don't even represent the same thing when they're talking about it. So in fact, both of the graphs are accurate, and they show the data from reputable sources. So the higher income do pay more taxes, but they also get more benefits.